Good morning, everyone. So that day we have started with eigenvalues and eigenvectors. We will solve few more problems based on that. Next example. Yeah, the next problem. Find the eigenvalues and eigenvectors of the matrix 1, 0, 0, 0, 3, minus 1, 0, minus 1, 3. So do you remember what was the characteristic equation? Any one of you remember? How did we start? So whatever, I'll just repeat that. So whatever is the given matrix, we'll name it as A. So let A be the given matrix, lambda be any scalar, and I is a unit matrix. Then the matrix A minus lambda I is called as the characteristic matrix. Determinant of A minus lambda I is called as the characteristic polynomial. And determinant of A minus lambda I equal to 0 is called as the characteristic equation. We are not able to see the presentation mode of the PPT, right? Am I audible?
Yes.
Yes? Okay. Okay. But I'm not able to see the presentation mode here because it's showing the full slides right now. I don't know what is the reason. Anyway, okay, so our aim is to find determinant of A minus lambda I equal to 0. So we knew that we had a formula for that. Anyone remembers the formula? Lambda cube minus, in bracket, what do we have? Lambda cube minus sum of the diagonal elements into lambda square plus sum of the minors of the diagonal elements into lambda minus determinant of A equal to 0. The fourth slide is seen now. PPTs are not moving, I think. Can you see the fourth slide? No, it's not moving. No, what is the reason? One sec. I don't know why it is not working. The presentation slideshow is not working here. Okay, we will continue that. So A is the given matrix. We have to find the characteristic equation. And after finding the characteristic equation, we have to find the roots of that. And once we get the roots of that, those roots are called as the eigenvalues. So we know to calculate the characteristic equation by using the formula lambda cube minus sum of the diagonal elements of A into lambda square plus sum of the minors of the diagonal elements of A into lambda minus determinant of A equal to 0. So first, the diagonal elements are 1, 3 and 1, 3 and 3. So we have to calculate the minors of each of the diagonal element. So minor of the diagonal element 1. Minor of the diagonal element 1. So to calculate the minor of the diagonal element 1, we have now 1 is there in the first row and first column. So leave out first row and first column, the remaining determinant. So remaining determinant is 3 minus 1 and 3. So we are calculating the minor. Minor means the element whichever it is there in whichever rows and columns, leave that row and that particular column and calculate the determinant of the remaining elements. So now it is 3 minus 1, 3. So find the determinant 9 minus 1, that is equal to 8. Next, find the minor of the next diagonal element, which is 3. Now 3 is there in the second column and second row. So leave out second column and second row and calculate the determinant of the remaining. So 1, 0, 0, 0, 3. Now calculate the determinants. We will get 3 minus 0, that is equal to 3. Next, again finding the diagonal element, minor of the diagonal element 3. The next diagonal element 3, which is in the third row and third column. So we have to find the determinant of 1, 0, 0, 3, which is equal to 3 minus 0, that is equal to 3. Next, find the determinant of A. Now, determinant of A, either you can use calci and calculate the value of determinant of A, or you can do it manually. So 1 into 9 minus 1 minus 0. This should be minus, I think. No? Minus 0 or plus, whatever is that, it should be minus here. Minus 0 into 0 minus 0 plus 0 into again 0 minus 0, which is equal to 8. Now substituting everything, I told you this formula is applied when we have a 3 by 3 matrix. Okay, this formula is applied only for 3 by 3 matrix. Otherwise, we have to calculate determinant of A minus lambda I equal to 0. Okay, when we have a 3 by 3 matrix, then we can apply this formula to get this characteristic equation. So we have now lambda cube minus sum of the diagonal elements of A. That is equal to 1 plus 3 plus 3. So 1 plus 3 plus 3 into lambda square plus sum of the minors of the diagonal elements of A. So we have got the minors as 8, 3 and 3, adding all the 3 into lambda minus determinant of A, which is 8, that is equal to 0. Now calculating or simplifying, we will get lambda cube. 3 plus 3, 6 plus 1, 7, that is 7 lambda square. 8 plus 6, that is 14 lambda, minus 8 equal to 0. When we simplify this, we get lambda is equal to 4, 2 and 1. 4, 2 and 1. Is it okay, the values? Please check the roots using calci. Yes, it's right. Okay. Okay. So we have got the eigen values और the characteristic roots. तो हमें सबसे पहले क्या करना है, जो भी मैट्रिक्स है उसको ए लेना है, उसके बाद ये फॉर्मूला यूज करना है, लैम्डा क्यूब माइनस सम ऑफ द डायगोनल एलिमेंट्स ऑफ ए इंटू लैम्डा स्क्वायर प्लस सम ऑफ द माइनस माइनस डिटर्मिनेंट ऑफ ए. तो सबसे पहले हमें सम ऑफ द डायगोनल एलिमेंट्स, नाउ दीज आर द डायगोनल एलिमेंट्स 1 3 एंड 3, तो उसको ऐड करना है. फिर हमें सबके माइनर्स निकालने हैं, जितने भी डायगोनल एलिमेंट्स हैं उनके सबके माइनर. माइनर का मतलब होता है अगर डायगोनल एलिमेंट 1 लेना है. Now 1 is there in the first row and first column, so you have to leave first row and first column, calculate the determinant. ऐसे ही हर एक तीनों diagonal elements का निकालना है, and then adding all those things, getting the characteristic equation, and then finding the roots. Next we have to find the eigenvector. Next we have to find the eigenvector. Now eigenvectors are defined by matrix A minus lambda I into x equal to 0. Now this is the matrix A. If I write A minus lambda I, means each of or lambda is subtracted from each of these diagonal elements. तो जितने भी diagonal elements हैं उसमें से lambda subtract हो जाएगा. So we will get 1 minus lambda 0 0 0 3 minus lambda minus 1 0 minus 1 3 minus lambda. Capital X के बदले x1 x2 x3 लिखते हैं. It is equal to 0 0 0. Now for each of these eigenvalues, we have to calculate the eigenvector. मतलब हमको लैम्डा को 4 पुट करना है, x1 x2 x3 की वैल्यूज निकालनी है. फिर लैम्डा को 2 पुट करना है, x1 x2 x3 की वैल्यूज निकालनी है, and then lambda equal to 1. So we'll calculate that now. So this is a minus lambda into x equal to 0. There will be 3 cases because we have 3 eigenvalues. So for lambda is equal to 4. This is already we have done. I'm just repeating for those who were not there. When lambda equal to 4. तो यहाँ पे lambda के बदले 4 पुट करना है. lambda के बदले 4 पुट करना है. When lambda equal to 4, yeah, what happened, Nitesh? You raised your hand. What was the problem? You can write in the chat box. Now I can see because I have logged in through 2 devices. I can see how the eigenvalues came. Okay. तो eigenvalues के लिए हमने क्या किया था? We have calculated the roots of this equation. Okay, we have calculated the roots of this equation. ये equation कैसे मिला? Using this formula. This formula is applied only when we have a 3 by 3 matrix. ठीक है? तो जो भी roots हैं, use calci and calculate the roots of this equation. Go to mode equation and then 5 या 4 जो भी है वहां पे इसकी values निकालनी है. Clear, Nitesh? Yes, okay. एक बार when we get the eigenvalues, we have to calculate the eigenvector corresponding to these eigenvalues. We have 3 eigenvalues, so we will get 3 eigenvectors. जितने eigenvalues हैं उतने eigenvectors मिलेंगे हमको. Okay? So now the case 1 will be when lambda equal to 4. Case 1 is lambda equal to 4. Now when lambda equal to 4 मतलब हमको lambda को 4 put करना है. So we will get this as the matrix. Minus 3, 0, 0, 0, minus 1, 1, 0, minus 1, minus 1. हमने तीन केसेस लेने हैं. पहले केस लैम्डा इक्वल टू 4 लेना है. सो व्हेन लैम्डा इज इक्वल टू 4, 1 minus 4, 0 0 0 3 minus 4 minus 1 0 minus 1 3 minus 4. इसके बाद 1 minus 4 minus 3 हो जाएगा, 3 minus 4 minus 1 3 minus 4 again minus 1. Now again open this matrix or multiply these two matrices. We will get in the form of an equation. तो ये हो जाएगा minus 3x1 plus 0x2 plus 0x3 equal to 0 0 0. Similarly second equation and third equation. ओके तो सबसे पहले हमें आइगन वैल्यूज निकालनी है. आइगन वैल्यूज निकालने के लिए हमें कैरेक्टरिस्टिक इक्वेशन निकालना है, उसके रूट्स निकालने हैं. Those roots are called as the eigen values, and corresponding to each eigen value we have to calculate the eigen vector. तो lambda equal to 4 के लिए हमें 3 equations मिले. Now actually we can consider any two equations. लेकिन यहाँ पे अगर हम देखेंगे तो इक्वेशन नंबर 2 and 3 आर सेम. ओके एंड आई टोल्ड यू आइगन वेक्टर्स के नीचे 0 0 0 नहीं आना चाहिए. आइगन वेक्टर्स आर ऑलवेज अ नॉन जीरो वेक्टर. तो यहाँ पे इक्वेशन 2 and 3 आर सेम. सो वी कैन नॉट कंसिडर इक्वेशन 2 and 3. अगर दो अलग अलग इक्वेशंस हैं तो यू कैन चूज एनी टू इक्वेशंस. But in this case, equation 2 and 3 are same. So there is no other option either choosing 1 or 2 and 1 and 3 because 2 and 3 are same. So I am choosing 1 and 2. नहीं तो हम कोई भी दो equation choose कर सकते हैं. But in this case, because we are having equation 2 and 3 as same, we have to consider only we have only two equations actually. There are two equations. Now using the Cramer's rule. Cramer's rule में क्या होता है? We have to take, अगर x1 हमने लिखा है ऊपर, okay? अगर हमें now our aim is to calculate x1, x2, x3 की values. So to calculate x1, we write x1 upon, leave out this or neglect this x1 वाला coefficient, the remaining coefficient का determinant निकालना है. तो अगर मैंने x1 लिखा ऊपर तो x1 के coefficients को छोड़ना है, बाकी के coefficients का determinant निकालना है. मतलब 0 0 minus 1 minus 1. अगर x2 लेना है तो we will have a minus sign, that is from the formula only, minus x2 upon x2 के coefficients को छोड़ना है, बाकी के coefficients को लेना है. So minus 3 0 0 and minus 1. Then x3 लेना है तो x3 coefficient को छोड़ना है, minus 3 0 0 and minus 1. Again simplify these determinants. Now this minus sign is from the formula of the Cramer's rule. Okay? तो ये माइनस साइन सेकेंड में आता है, फर्स्ट और थर्ड में नहीं आता है. सो नाउ व्हेन वी सिंप्लीफाई दिस, माइनस 1 into 0 is 0, 0 minus 1 is 0 again. यहाँ पे 3 minus 3 into minus 1 will become 3 minus 0, and this will also become 3 minus 0. So we have 0 minus 1 1. So the eigenvector corresponding to lambda equal to 4 is 0 minus 1 and 1. Or you can write 0, 1 and minus 1. That is also okay. Any doubt in this eigenvector? Is it clear? Eigenvector? Yeah, okay. Yeah, Surajit, you have doubt? Huh? Yeah, Surajit. Huh? नहीं, then we have to calculate determinant of a minus lambda I. ये जो है ना, इसका डिटर्मिनेंट निकाल के हमें डिटर्मिनेंट को एक्सपैंड करके निकालना पड़ेगा उसका. ओके, नॉर्मली यू विल हैव 2 और 3. 2 में तो इजीली हो जाता है, 4 तो नहीं पूछेंगे. अगर पूछा भी तो डिटर्मिनेंट निकालना पड़ेगा 4x4 मैट्रिक्स का. That formula is only applied for a 3x3 matrix. Clear, Surojit? ठीक है? If it comes, I'll show you. अभी तो यहाँ पे 3x3 कर रही हूँ, एक 2x2 का कर लूंगी लास्ट में. 4x4 का तो अभी तक तो नहीं पूछा है, but if it is there, then we have to find. जैसे हमने ये मैट्रिक्स लिखा है ना, ऐसा 4x4 का मैट्रिक्स लिखना है और उसका डिटर्मिनेंट निकालना है to get the characteristic equation. ठीक है? Okay. Any other doubt? Yeah, yes. Huh. स्लाइड नंबर 4. हाँ या हाँ हाँ तो हमें निकालना पड़ेगा डिटर्मिनेंट ऑफ a माइनस लैम्डा आई. सपोज वी आर हैविंग ओनली 1 0 0 3. ठीक है, तो हम क्या करेंगे, a माइनस लैम्डा आई मैट्रिक्स फॉर्म करेंगे. तो व्हाट विल बी a माइनस लैम्डा आई, 1 माइनस लैम्डा 0 0 3 माइनस लैम्डा, इतना ही रहेगा, है ना. फिर हमें उसके डिटर्मिनेंट को सॉल्व करना है बाय यूजिंग द नॉर्मल डिटर्मिनेंट, जो फॉर्मूला रहता है ना, वो फॉर्मूला यूज करके हमें उसका निकालना है. तो दिस इनटू दिस माइनस दिस इनटू दिस विल बी इक्वल टू 0. Not, huh? No, this is only for 3 by 3, 3 by 3 matrix. In general जो है, it is, see this one, this is a general formula. This is the general formula. Determinant of a minus lambda I equal to 0. ये general formula है. For 3 by 3, we can apply that formula. For all the other ordered matrix, you have to calculate. अगर ये determinant लिखना है हमको और इसको ओपन करना है, जैसे जो नॉर्मल हम लोग ओपन करते डिटर्मिनेंट को, वैसे ही इसको ओपन करना है. Okay, it becomes a complicated one when you use direct determinant. 2 by 2 it is okay, but if it is 4 by 4, it's going to be complicated only. Okay, clear? Yeah. So similarly, now we have to find the eigenvectors corresponding to the next two eigenvalues. ये हमारा पहला वाला हो गया. अभी next निकालना है. Next eigenvalue is lambda equal to 2. Next eigenvalue is lambda equal to 2. So again put lambda equal to 2, form 3 equations, take any 2 and use Cramer's rule to get the values. तो अभी हमको लैम्डा को 2 पुट करना है. तो 1 माइनस 2 0 0 0 3 माइनस 2 माइनस 1 0 माइनस 1 3 माइनस 2. Simplifying, 1 minus 2 minus 1 0 0 0 1 minus 1 0 minus 1 1. फिर से हमें इक्वेशन लिखना है. Now, can we choose equations 2 and 3? Can we choose equation 2 and 3? अगर सेम है तो हम नहीं चूज कर सकते, बट 2 and 3 का अगर हमने चूज किया ना, तो देखो डिटर्मिनेंट नीचे क्या आता है. Harsh is saying yes. Okay. ऋषिकेश नो. यस, अगर हमने इसको चूज किया, दोनों सेम है. अगर मैंने एक माइनस साइन से मल्टीप्लाई किया, दोनों सेम हो जाएगा यहाँ पे. ओके, सो वी कैन नॉट टेक इक्वेशंस 2 and 3 इन दिस केस आल्सो. सो टेक इक्वेशन 1 and 2 और 1 and 3. अगर तुम्हें डिटर्मिनेंट निकाला, सपोज मैंने x1 को छोड़ा, तो डिटर्मिनेंट क्या आएगा, 1 minus 1, दैट इज 0. अगर x2 का निकाला तो अगेन 1 minus 1. ओके, इट्स गोइंग टू बी, if it is not becoming, then it is okay. अगर देखो, अगर x2 और 3 का सेम आ रहा है तो we can do that. अगर नहीं आ रहा है 0 तो it's fine, no problem. तो 0 आएगा बिकॉज यहाँ पे आप having 0 into 0, everything will become 0 only. x2 का भी चूज किया तो 0 minus 0, x3 का भी चूज किया तो 0 minus 0, और यहाँ पे 1 minus 1, everything will become 0. So we cannot choose equation 2 and 3. So choose 1 and 2 or 1 and 3. तो मैंने 1 and 2 चूज किया है. Now write x1 upon. हमें क्या करना है, x1 वाले कोएफिशिएंट को छोड़ना है, x2 और x3 के कोएफिशिएंट्स को लेके डिटर्मिनेंट निकालना है. तो when I write x1 in the numerator, the remaining coefficients are 0 0 minus 1 minus 1. तो यहाँ पे लिख दिया 0 0 minus 1 minus 1. Equal to, now this minus sign is there for the formula, so minus x2 upon. अभी हमें x2 के कोएफिशिएंट को छोड़ना है, सॉरी x2 के कोएफिशिएंट को छोड़ना है, तो रिमेनिंग कोएफिशिएंट्स आर माइनस 1. एनी डाउट
मैम?
हाँ,
मैम कंसिडरिंग इक्वेशन में सेकंड इक्वेशन 0x1 प्लस x2 माइनस x3 है ना?
हाँ, दिस इज प्लस ना, करेक्ट, दिस इज प्लस। मैंने शायद सेकेंड और फर्स्ट और थर्ड लिया लगता है, नहीं नहीं नहीं, इट्स प्लस ओनली, यस आई हैव टेकन डिफरेंट, यस इट्स प्लस, करेक्ट, यू आर राइट, प्लस, करेक्ट है। हाँ, तो अभी क्या होगा फिर, x1 विल बी, तो ये 1 हो जाएगा, राइट, ये 1 हो जाएगा, माइनस x2 अपॉन माइनस 1 0, 0 माइनस 1, और अगर x3 लिया तो माइनस 1 0, 0 एंड 1 हो जाएगा, ओके, करेक्ट। तो अभी दिस विल बिकम 0, दिस विल बिकम 1, दिस विल बिकम माइनस 1, ओके, this also will become minus 1. और 0 1 1 हो जाएगा, अभी ठीक है, इज इट ओके नाउ? Sign is changed, correct. Now it's fine, ठीक है, yeah. So the eigenvectors, I can either you can write 0 1 1, or you can write 0 minus 1 minus 1, anyway you can write, corresponding to lambda equal to 2. So next we calculate for the next eigenvalue. Next क्या था eigenvalue? Lambda equal to 1. Lambda equal to 1. Now when lambda equal to 1, put lambda equal to 1 there. So 1 minus lambda. So 1 minus 1, 0, 0, 0, 3 minus 1, minus 1. Putting lambda equal to 1. Everywhere lambda equal to 1. Again, we will get 3 equations. Write down those three equations and calculate the values of x1, x2. Now, which two equations, 1 and 2, can we consider? 1 और 2 अलग अलग इक्वेशंस हैं, लेकिन अगर हम सिंप्लीफाई करेंगे तो 0 0 आ जाएगा, चेक कर लो बस। अगर 0 0 आ रहा है नीचे तो वी कैन नॉट कंसीडर दोस टू इक्वेशन, दैट इज ओनली द कंडीशन। तो यहाँ पे अगर हमने फर्स्ट और सेकंड यूज किया तो हर जगह 0 0 0 ही आएगा, बिकॉज एवरी द फर्स्ट इक्वेशन एवरी कोएफिशिएंट्स आर 0, तो कोई भी डिटर्मिनेंट लेंगे हमको हमारा आंसर 0 ही आने वाला है। तो वी कैन नॉट कंसीडर इक्वेशन 1, we'll consider equation 2 and 3. Equation 2 and 3. So now considering equations 2 and 3, फिर से क्रेमर्स रूल यूज करना है, x1 अपॉन x1 के कोएफिशिएंट को छोड़ के बाकी दो वेरिएबल्स के कोएफिशिएंट्स को यहाँ पे लिखना है। सो -1 -1, जस्ट चेक द साइंस अगेन, इज इट ओके? So 2x1 minus 2x2 minus x3 minus x2 plus 2x3. Okay. So x1 upon -1 -1 -1 2, x2 upon 0 -1 0 and 2, and x3 upon 0 -1 0 -1. Check the determinant. So -2 into -1 into 2, that's -2 -2 -1. Yeah. Again, there is a mistake. Yes. Yes, yes, I agree. Plus 2 minus x3, 0, x1 plus 2. So we will have 0. This is okay. Mine यहाँ पे 2 हो जाएगा फिर वो. minus 1 minus 1 2 0 minus 1 0 2 तो 0 यहाँ पे 2 हो जाएगा. 0 2 and 0 minus 1. तो now आंसर क्या आएगा फिर 4 minus 1, right? 4 minus 1 0 and this is 0. 3 0 0, right? The answer remains the same, 1 0 0. Now it's okay. 3 0 0 आ रहा है बराबर. The whole this chapter, this module 1 theory of matrices, everywhere you have to find the eigenvalues, and most of the methods you have to find the eigenvectors also. Okay, so we have got 3 eigen. This is also x3 actually. यहाँ पे third eigen है तो x3 हो जाएगा वो भी. Next to x3. Any doubt in this? Can you move to the next problem? Similar problem, but with repeated root. What to do when we have a repeated root? Next example. So all these steps, whatever, this parts are not required because we're not going to calculate by using the determinant formula. So this step is not required. Yeah, 3 0 0. See again, how many marks all depends upon which type of exam you are having. As per, it is asked for 8 marks or 6 marks if it is an offline exam. If it's online, I don't know. Because last time you had all 5 marks question, even with the questions which were supposed to be asked for 8 marks, they'd asked for 5 marks also. We cannot say it's like mostly it is 8 marks or 6 marks, depending upon like what type of roots you are having. If it is repeated, they might ask for 6 marks. If it is non-repeated, they might ask for 8 marks. Okay. Yeah, the next problem, 3 10 5 minus 2 minus 3 minus 4 3 5 7. These steps are not required. Only these steps are required only when you have a matrix of any other order other than 3. When we have, then we have to use this formula. Otherwise, directly you can apply the formula for that. So find the minus. I don't know why this is not happening in the presentation mode. Okay, same way, we have to find the minus of each of the diagonal elements. Just check all the values again. अगर मैंने पहला diagonal element लिया 3, इसका माइनर निकालना है तो हमें फर्स्ट रो और फर्स्ट कॉलम छोड़ना है, बाकी का डिटर्मिनेंट. सो -3 -4 5 and 7. So -21 plus 20, which is -1. सिमिलरली -3 का निकालना है तो सेकेंड रो और सेकेंड कॉलम को छोड़ना है, बाकी के डिटर्मिनेंट्स 3 5 3 7, 21 माइनस 15 दैट इज 6। फिर अगर 7 का निकालना है तो थर्ड रो और थर्ड कॉलम को छोड़ना है, 3 10 -2 -3, so -9 plus 20 which is 11। Determinant of A, just check the value of determinant of A also. Determinant of A, you know how to calculate using calci, all of you? Yes, no? Okay. Yeah, so determinant of A is equal to, is it okay, 12 then? The value is 12, is right? Substituting all these values, the eigen diagonal element, that is 3 minus 3 plus 7, then the sum of the minus, and then minus determinant of A equal to 0. We have lambda cube minus 7 lambda square plus 16 lambda minus 12 equal to 0. The value is not 12, Uttara. Let's check the value of determinant of A. Just tell me. 10 into 21 minus 15. How did you get, Uttara? 10 means you will leave out this column and this also. Minus 14 plus 12. 21 minus 15 is for the... You have done something wrong there. Yeah, got it, no? Right, not 12? Huh. Okay. So, and just check the roots also. Roots of this equation, lambda cube minus 7 lambda squared plus 16 lambda minus 12. Yeah. Yes, the roots, please check the roots. 3 2 2. Is it okay? The values, just check the roots. Three, two, two. Okay. What about others? Three, two, two. Okay. So now we are having, in the previous problems, we had non or distinct roots. 4 2 1, 1 2 3. We had all distinct roots. Now we are having a repeatable. So we'll see what is to be done for that. Now the first eigenvalue, when lambda equal to 3, we will calculate the eigenvector. So we have to form the matrix A minus lambda I into x equal to 0. So we have found this. Whatever is the matrix A, subtract lambda from each of the diagonal elements and then replace capital X by x1, x2, x3. So now case 1, when lambda equal to 2. Lambda equal to 3. When lambda equal to 3, so putting lambda equal to 3, again writing it in the form of equations using Kramer's rule, everything is same. Okay? If you are getting 0, 0, 0, then only we have to just use different methods without using the Kramer's rule. Kramer's rule can be applied till you get the answer as a non-zero eigenvectors. अगर 0 0 0 आ रहा है तो ही we have to go for a different method. कोई भी equations लिया, अगर 0 0 0 आ रहा है, then we have a different method. Otherwise, you can apply always the Kramer's rule. So now 3 minus 3 is 0, minus 3 minus 3 is minus 6, 7 minus 3 is 4. Writing it in the form of equations. Abhi, I think we can consider any two. All the three are different equations, I think. Here, all the three are different equations. We can consider any two equations. I have considered 1 and 2, but you can take any of the two equations. 2 and 3 le lo, ya 1 and 3 le lo, it is fine. I've taken 1 and 2. Again, using the Kramer's rule, x1 upon. You can try with the different equations also. तो अगर x1 निकालना है तो x1 वाले कोएफिशिएंट्स को छोड़ के बाकी वेरिएबल्स के कोएफिशिएंट्स को लिखना है. So 10, 5, minus 6, minus 4. Please check the signs again. Is it okay? 0x1, 10x2, 5, minus 2, minus 6, minus 4. Okay. फिर x2 लेना है तो 0, 5, minus 2 and minus 4. x3 लेना है तो 0, 10, minus 2 and minus 6. So minus 40 plus 30, 0 plus 10, and 0 plus 20. We will have minus 10, 10, 20. You can cancel minus 10 throughout or 10 throughout and get the first eigenvector. Is it okay? Minus 1, 2 या 1, 1, minus 2 भी ले सकते हैं. That is fine. ठीक है ना, equation, this eigenvector corresponding to lambda equal to 3. So we'll go to the next eigenvector, which is equal to 2. We had 3, but out of that 2 was repeated 2 times, which means we have to calculate only for 2 eigenvalues here. Lambda equal to 3 and lambda equal to 2. So अगर lambda equal to 2 लेना है तो putting lambda equal to 2 in the equation a minus lambda into x equal to 0. लैम्डा के बदले 2 पुट करना है. When lambda is equal to 2, we will get the matrix as 1, 10, 5, minus 2, minus 5, minus 4, 3, 5, and 5. Okay, writing it in the form of equation. So x1 10x2 plus 5x3 equal to 0. Minus 2x1 minus 5x2 minus 4x3 0. 3x1 plus 5. We're just opening the bracket, open this matrix. We are multiplying these two matrices. Again, take any two equations. I'm considering 1 and 2. Either 1 and 3 le lo or 2 and 3 le lo. Any combinations will give the same answer. Use Cramer's rule. सो x1 अगर निकालना है तो x1 के कोएफिशिएंट को छोड़ के x2 और x3 के कोएफिशिएंट्स यहाँ पे लिखने हैं. तो 10 5 minus 5 minus 4. x2 है तो 1 5 minus 2 minus 4 and x3 is 1 10 minus 2 minus 5. Simplify x1 upon minus 40 plus 25 minus 4 plus 10 minus 5 plus 20. Minus 40 plus 25, which is minus 15, minus 4 plus 10, that is 6, minus 5 plus 20, which is 15. We can cancel 3 throughout, so we can write minus 5, minus 2, and 5. Anyone has tried with 1 and 3 or 2 and 3? Same answers are there? Same are there, na? So we have only 2 eigenvectors. There are no other combinations we can take. You have taken which one? Yes, 1 and 3 or your 2 and 3? क्या लिया है? 2 and 3. Anybody has taken 1 and 3? इसने try किया 1 and 3 same answers आ रहे हैं, just check कर लो एक बार. It is going to be the same only. Maybe you may get 5 2 minus 5. That may be the difference. That's it. Only एक minus sign का difference हो सकता है because we can multiply throughout by minus sign also here. So we have only 2 eigenvectors in this case because the eigenvalues were 3 and 2. So eigenvectors also we are getting only 2 because there are no other combinations which we can consider and get the eigenvector. One more we can do on the same repeated root. Minus 2, 2 minus 3. Let's try to find the eigenvalues of this matrix by, again we have a 3 by 3 matrix, we can apply the formula. So just tell me, before going to the next slide, just if you can calculate the eigenvalues or the roots of the characteristic equation. And please write the answer in the chat box, the eigenvalues. सबसे पहले हमें माइनर निकालने हैं, माइनर्स ऑफ 2 1 एंड 0, तीनों को ऐड करना है, डिटर्मिनेंट ऑफ ए निकालना है और वो इक्वेशन में सब्स्टिट्यूट करना है. Don't forget to write your attendance also in the chat box, those who have not written. Anybody has got the values? Five minus three minus three. Okay, so Rojit has got five minus three minus three. What about others? The equation is going to be lambda cube minus 2 plus 1 plus 0, which is minus 1 into lambda square plus sum of the minors of the diagonal elements minus determinant of A equal to 0. So minor of the diagonal element minus 2. Leave out first row and first column, remaining determinants. 1 minus 6 minus 2, 0. We will get 0 minus 12, which is minus 12. Minor of the diagonal element 1 will be, leave out second row and second column. So 0 minus 3, that is minus 3. And similarly for this diagonal element, minus 2, 2, 2, 1, that is minus 2, minus 4, which is minus 6. Determinant of A comes out to be 45. Just check the values. The roots, even I have got 5 minus 3 minus 3. So again, we have a repeated root here, minus 3. So first we will find for lambda equal to 5 and then for lambda equal to minus 3. So अगर lambda equal to 5 के लिए आइगन वेक्टर निकालना है तो सब्स्टिट्यूटिंग इन मैट्रिक्स A माइनस लैम्डा आई इंटू एक्स, यहाँ पे ये मैट्रिक्स है. ओके, जब हम लोग निकालते हैं इट इज डिटर्मिनेंट ऑफ A माइनस लैम्डा आई टू गेट द कैरेक्टरिस्टिक इक्वेशन. Putting lambda equal to 5. When lambda is 5, minus 2 minus 5, 1 minus 5, 0 minus 5. So minus 7, 2 minus 3, 2 minus 4 minus 6 minus 1 minus 2 minus 5. Rewriting it in the form of equation again. All the three are three different equations. So you can choose any two equation and use Cramer's rule to get the values of x1, x2, x3. Please check the answers. So if I choose the first and second equation, then x1 upon 2 minus 3 minus 4 minus 6 minus x2 upon, इसको छोड़ना है तो minus 7 minus 3 2 minus 6 and x3 upon minus 7 to 2 minus 4. So minus 12 minus 12, 42 plus 6, 28 minus 4. So minus 24, 48, 24. 1, 2 and minus 1 or minus 1, minus 2 and 1. Because you can cancel minus 24 also throughout. So we can get 1, 2 and minus 1. I've cancelled only 24, so we get minus 1, minus 2 and 1. This is corresponding to lambda equal to 5. Next, lambda equal to minus 3. If there is any mistake, please let me know so that I can correct. Case 2 when lambda equal to minus 3. So many steps you can skip because these two steps are not required. Directly you can take it from 1 and 2 here itself. Now when lambda equal to minus 3, we get the matrix as 1, 2, minus 3, 2, 4, minus 6, minus 1, minus 2, minus 3, minus 1, minus 2 and 3. Now if we see equation 1, 2 and 3, are they same? If we take equations 1, 2 and 3, तीनों की तीनों same है, कुछ difference है कोई equations में? Or which two equations are same? Equation 1 is having 1, 2 and minus 3. अगर मैंने यहाँ पे क्योंकि right hand side 0 है, if I multiply throughout by if I divide throughout by 2, I will get 1, 2 and minus 3. तो 1 and 2 same हो जा रहा है और यहाँ से अगर मैंने माइनस साइन मल्टीप्लाई किया तो यहाँ पे भी 1, 2 and 3 1, 2 and minus 3 हो जाता है, which means equations 1, 2 and 3 are same. कोई भी equation लो, you're going to get only 0, 0, 0. Whichever equations you take, either 1, 2, 1, 3 or 2, के तीनों same है. So when you find the determinant, it's going to be 0, 0, 0 in all the three cases. ठीक है? मतलब we are having only one equation, right? We are having only one equation. All the three are, we are having only one equation, x1 plus 2x2 minus 3x3 equal to 0. तो हमें क्या करना है? You can take any values of x1, x2, x3 satisfying this equation. You can take any values of x1, x2, x3 satisfying equation. You can take two different values because we have two eigenvector. Minus 3 is a repeated eigenvector, repeated twice. तो मैंने यहाँ पे क्या किया, x1 की वैल्यू 2 पुट कर दी, x2 की वैल्यू -1 पुट कर दी और x3 की वैल्यू 0 पुट कर दी, and see whether it is satisfying the equation. Any three values of x1, x2, x3, so that when we substitute those values, the answer has to be equal to 0. ठीक है? तो मैंने यहाँ पे क्या लिया है, 2 minus 1 0. Any other, I have taken 3 0 1 also. Any different combinations you take, any two different combinations you can take, because we have -3 repeated 2 times. Infinitely many solutions you will have. Okay, और कौन कौन से possibilities हैं? एक तो हो गया 2 minus 1 0, 3 0 1. Any other possibility? ताकि आंसर 0 आ जाए. Take any three values, 0, 3 and 2. Okay, fine. 0, 3 and 2, that is also okay. Any values of x1, x2, x3 satisfying that equation. ठीक है, क्योंकि -3 यहाँ पे 2 बार रिपीट हो रहा था, तो इसीलिए हमने 2 वैल्यूज निकाली है, उसकी 2 आइगन वेक्टर्स निकाले हैं. In the previous problem, it was not possible to get a single equation. We had only 2 equations, so there was only one eigenvector. Any value satisfying this equation, we can consider to write the eigenvectors. Okay, so when we have, instead of 3 equations, when we have only a single equation, you give any values. Okay, दिशा हमने क्या की, 3 equations are same. ठीक है, कैसे भी ले लो, 1 2 -3. यहाँ पे भी अगर 2 को मैंने कैंसिल किया तो 1 2 -3 हो जाता है. यहाँ पे भी अगर -1 को कैंसिल किया तो 1 2 and -3 हो जाता है. 5 5 5. बट हाउ 5 5 5 0 आता है आंसर? ओके फाइन, चलेगा चलेगा, you can do that. That is equal to 1 1 1. Like 5 5 5 is same as 1 1 1, है ना? तो 1 1 1 भी है तो भी चलेगा. I think 1, yeah, 1 1 1 also will do. Fine. Okay, Disha, you were asking now what to explain. So I've got 3 equations, but when we calculate or when we use Kramer's rule, कोई भी तुम 2 equations लोगे, the answer is going to be 0 0 0, which is not possible because eigenvectors are always non-zero vectors. Okay, तो हमने क्या किया, all the 3 are same, तो एक equation को ले लिया हमने. Give any values of x1 x2 x3, कोई भी वैल्यू ले लो, बट उसका अगर यहाँ पे सब्सटीट्यूट करेंगे तो आंसर 0 आना चाहिए. तो आई हैव टेकन 2 - 1 0, मतलब x1 को मैंने 2 लिया है, x2 को -1 लिया है, x3 को 0 लिया. तो आई गॉट द आंसर एज 0. नाउ लाइक सुरोजित हैज सेड 0 3 2, x1 को 0 लिया है, यहाँ पे 3 लिया है, यहाँ पे 2 लिया है, अगेन आंसर इज इक्वल टू 0. अभी यश सेड 5 5 5 और 1 1 1, दैट आल्सो सैटिस्फाइज दिस इक्वेशन. Any values satisfying this equation can be taken as the eigenvector. Any other doubt? Any other doubt? Disha, understood? Yes? Okay. Okay. So if you are having only one equation and you have 2 eigenvalues corresponding to that, then you give any values of those 3 variables to get the values of the eigenvector. I have given one more. You can try that because it's already time. You can go for the next lecture. You can try this. I will share this PPT. Please join Google Classroom, those who have not done. Also, I'll upload this PPT also there. Try next problems also. Okay? See you in the next lecture with the next topic. Thank you. Before leaving, please write down if you have not written your attendance in the chat box.